هالسؤال بعد كان في واحد من assignments. So the following elementary reversible reaction takes place isothermally with a negligible pressure drop in a plug flow reactor. The inlet stream is pure A with a molar concentration of 0.4 mol per liter. The equilibrium constant K is equal to 25 mol per liter. The reaction occurs in the liquid phase with an inlet volumetric flow rate V0. The rate constant for the forward reaction is Kf, while that for the backward reaction is Kb, such that, okay, this is the reaction. بعدين, we're asked to find the equilibrium conversion and the concentration of A and B at equilibrium, and the equation that expresses the differential change of the conversion with respect to the volume used in the reactor as a function of these. So let's solve the question حبة حبة. أول شيء الريت لو عندنا negative RA is equal to KA, I'll call this KA, CA minus KB, CB, CC. This is the rate of the forward reaction, and this is the rate of the reverse reaction. Okay, بعدين ال KE is given. We know that KE is equal to the concentration of the products over the concentration of the reactants to the power of their stoichiometric coefficient. So in this case بيكون ال KE is equal to CBCC over CA. Okay, and what are the givens في السؤال? We are told that at the inlet we have pure A, so YA0 is equal to 1, and CA0 is given as 0.4 mol per liter. The equilibrium constant is given as 25 mol per liter. Okay, عندنا isothermal, isobaric, and it occurs in a PFR at the liquid phase. So for the stoichiometry we're going to use liquid phase flow reactor, this equation. Ci is equal to Ca0 theta I plus stoichiometric coefficient of I times x. So حق ال A بيكون, شوفوا, you don't have to write this every single time, بس as a piece of advice دوم يوم بتحلون أي سؤال do this. أول شي اكتبوا ال theta for each one, so theta of A, theta of B, و theta of C. بعدين ال stoichiometric coefficient of each one. أنا أسوي هالحركة عسبة يوم أي أحل دايركت أعوض، لأن ساعات يعني من التوتر تضيعون، فتحطون أرقام المفروض they're not supposed to be there. Anyways, فالثيتا A is equal to 1. الثيتا B والثيتا C، الثيتا B هي عبارة عن شو؟ NB0 over NA0، بس نحن ما عنا initially B، this will be 0. And the same applies for C. بعدين the stoichiometric coefficient of A is -1, B is 1, and C is 1. اوكي، فدايركت الحين نقدر نعوض هني حق ال A وال B وال C. CA is equal to CA0 1 minus x، و CB is equal to CA0 times x، و CC is equal to CA0 times x. اوكي، بعدين نفس ما قلنا ان ال KE is equal to CB CC over CA، ونحن عنا ال expression for each one. So CB is equal, CB is equal to CA0 times x، و CC is equal to CA0 times x over CA, which is CA0 times 1 minus x. This is the same as CA0 squared times x squared. So I'm gonna write it in a simpler form. CA0 squared x squared over CA0 1 minus x. هاي السكويرد اللي هني بتروح مع ال initial concentration اللي تحت. So we're gonna have an expression for K. Ka is equal to Ca naught times x squared over 1 minus x. Okay, what are we looking for? عندنا ال Ke وعندنا ال initial concentration. We're trying to find ال x. So let's substitute with the numbers that we have. 25 is equal to Ca naught. I think it was given as 0.4, yeah. 0.4 x squared over 1 minus x. I think إذا حطيته في الكالكوليتر يطلع لكم بالشفت سولف يطلع لكم الرقم. بس just in case we're gonna solve it in details. So بنجيب هاي ال 1 minus x فوق بيكون عندنا 25 times 1 minus x is equal to 0.4 x squared. بعدين we're gonna multiply whatever is inside بال 25. So 25 minus 25x is equal to 0.4 x squared. بعدين we want all of this to equal to 0. So بنسوي بنجيب this to the other side أو العكس. Both would work. So 0.4 x squared plus 25x minus 25 is equal to 0. بنحط هالإكسبريشن في الكالكوليتر mod 5 و 3. بيطلع لنا two values حق ال x. X is equal to 0.9845 and x is equal to negative 63. Of course we're gonna take this value لأن x cannot be larger than 1. Okay, for the second part of the question they're asking us to find the concentration of A and B at equilibrium, and we already have these expressions. Okay, بناخذهن نفس ما هن. I'll just copy them and we're gonna paste them right here. Okay, so Ca is equal to Ca naught, which is 0.4 times 1 minus x, which we just found as 0.9845. So Ca is equal to 6.2 times 10 to the power negative 3 molars. Cb is equal to Ca naught times x, so 0.4 times 0.9845, which is 0.392 molars. And this makes sense لأنه يوم يخلص الرياكشن بيكون عندنا a very small concentration of the reactant and a higher concentration of the product. Okay, بعدين what are they asking us to find? The equation that expresses the differential change of the conversion with respect to the volume used in the reactor as a function of the volume, the concentration, Ka, Kb and x only. Okay, perfect. We're gonna use نحن عندنا plug flow reactor, so we'll use this one. Fa naught dx over dv is equal to negative Ra. Ra عندنا already طلعناها في البداية اللي هي هذه. So بنعوضها مكان ال Ra. So بيكون عندنا Fa naught dx over dv is equal to Ka Ca minus Kb Cb Cc. زين، مكان ال Ca وال Cb وال Cc بنحط هالexpressions اللي طلعناهن هني. ليش؟ لأن it's asking us to find ال equation as a function of Ca naught. ما عنا لا Cb ولا Cc ولا Ca في اللي هو يبغاه. So بنحط ال expressions Fa naught dx over dv is equal to Ka. Ca is Ca naught times 1 minus x minus Kb, and Cb is Ca naught times x, or Cc is Ca naught times x, so this is squared, they're both squared. بعدين we're gonna divide both sides by Fa naught لأن نحن نبغى الإيكويجن حق هذا. Okay, so Fa naught over Fa naught over Fa naught over FA naught. This will cancel this. بعدين ال dx over dv is equal to، نحن نعرف ان ال FA naught من هني ال C of anything is equal to ال F over ال volume. So ال FA naught is equal to CA naught times V naught. So بنحط ال equation نفس ما هي KA CA naught 1 minus X over instead of FA naught بنحط CA naught times V minus KB CA naught squared X squared over CA naught times V. هاي CA naught بتكنسل CA naught والسكويرد بتكنسل هذه، فبيكون عنا dx over dv is equal، عنا the same denominator so we can combine them. KA 1 minus X minus KB CA naught X squared over V. Yes, this is everything that was asked in the question. وخلصنا السؤال. هاي الفاينل answer حق part C.